Ruby, Python, Java, Scala, that kind of stuff.
So can you give first like a 2-second background for you and where you're coming from and what you're doing? That way to kind of get a depth on it.
So if you guys haven't met me before, my name is Mark Kegel. I work remotely for a company down in Austin called Vast. I work as a software engineer, mostly as a data engineer. So one of my primary jobs is taking models that data scientists put together and getting them into production. So it's actually really fun, very interesting. And my screen is all kinds of interesting there now.
And you use Scala to do so.
Yeah,
Yes.
mostly Scala, but also a lot of Java. We're probably 50-50.
Also, I have one question to add.
Okay.
Spark, using Scala and Spark using Python, like is there any limitation on you using Python for Spark? Or like is there any edge like if I should use Spark?
You're always going to be limited by the bindings. I don't know enough about Spark, but you're going to have to go through a translation layer. So there's probably going to be a performance overhead right there. It's going to be a constant factor, but 100 billion is a constant factor, so it could be really, really large. I don't know. In general, Python native code tends not to be all that performant. If you want performance, you have to drop down into C. The awesome thing about Python is that dropping down into C is ridiculously simple. So you can actually get really good performance, optimize your loops very tightly, and then do the rest in Python. And that's what a lot of folks do. That's why libraries that are written in Python actually tend to ship with native objects. So.
So are you saying if you're using Spark, go with Python?
No.
No.
I'm saying
Scala.
I'm saying use what's best for you. So like the data scientists that I work with write exclusively in Python.
Okay.
So learning that API and interfacing with it is totally the best choice for them. But if you have a bunch of Scala developers on hand, yeah, use Scala. So,
We were using DataStax Enterprise, so that comes with Spark installed on top of Cassandra.
Mhm.
So the recommendation we had from DataStax Enterprise was to write the code in Scala. That's how we started. So.
Okay.
Yeah, definitely. A lot of people do that, yeah. But like you said, the data scientists, they love the pandas.
Yeah.
The Python. It's a table and data frames.
And so I gave a presentation not too long ago about the different data frames. So Python or Pandas is a data frame library.
Right.
It looks really nice because there's a lot of different Python tricks that you can do to make your code really concise. Decoding that into Scala, it's a 10 to 20% increase, but it's not like a 100-fold increase like it would be with Java. So.
Yeah.
No, I don't actually have. I thought I was presenting.
Did it not click on for you?
We can let's just try to get a feel for what the languages look like when written out, and some of the general differences between Python. I don't have any Groovy, so we can't compare that. We at least have the 3 languages that we can compare. So in general terms, Java is going to be much closer to Scala, right? Because Python as a language is dynamically typed. You can basically go through and at any point, so its scoping rules are the same, but you can write expressions just about anywhere.
Thank you.
Oh yeah, that's a good idea. So if you wanted to just declare a variable, you can do that. And now X is basically this global variable you can reference anywhere. And if folks want to be able to see that, I should make the code bigger. So you can't really do the same thing in Java. Everything has to, it's, kingdom of the nouns, right? So everything has to have an owner. Which I really love that idea, by the way. So,
I guess in language training I never heard of it.
yeah.
I skipped. Yes.
So the Python is made a little bit more complicated because it never really, it started off with objects, but objects were never really its focus. It started off a lot with expressions and small ways to put together code and make it bigger, and they sort of glommed on with classes as a way to organize it because OO has been big for 25 years, and that's sort of been its operating principle. So you can go through in Python and you can create what they call a class, and the class is very similar to what people would normally think of in that yeah, there's a collection of methods, and you can create an object as an instance of this class, and you can call the methods on it, but it's sort of the very free-form way of creating objects, in that methods are just sort of attached in rather than a really integral part of what the class is, if that makes sense. And it has a lot to do with how objects underneath are represented. So for example, when I do something like that to create just an empty map literal, what I'm actually doing is creating a reference object off to an actual static instance of a class. So Python has this notion of a meta class that instantiates your types. And that meta class tells you at that point what methods you're going to have, because everything, remember, is going to be dynamic. So I can have, x equals the empty map, and I can, on the next line, say x equals 5. And this is really the essence of dynamic programming, in that the type of x is never fixed. It's just a name, it's a binding, and you can go off and do things with it. And if you want to dispatch something to x, like I want, and this is saying I can't do anything, obviously, so, and that only has, so if I wanted to call I don't even know what the hell this stuff is.
Laura.
Oh, interesting.
It
Okay.
just shoved in the standard filler. That's hilarious.
But this is, they use standard dot syntax to in some ways, I don't know if it's actually message passing. I think what it's actually doing, there's some hidden fields effectively. So everything in Python is more or less a map that you can go do a string name lookup, and then whatever it is that you can get back, you can kind of apply it and do expression stuff on it. So you can mess with that by doing stuff like this, because that's the name of the map that actually stores all of the hidden stuff for Python. The reason I'm telling you this, the way that it's implemented, is this stuff gets exposed every day to the Python programmer. It's actually really, really common to go through and be messing with this stuff. In fact, it's so common that they came up with the name monkey patching, because folks will just, oh, I don't like that method on this particular instance of this object. Let me swap it out for something better. It's an actual technique for folks to instantiate different objects of the same type, like we would be familiar with, and then just swap their methods around at runtime because of the code paths that they're going through.
That's about as mutatable as you possibly could be.
Exactly. And all of this is exposed to the programmer.
Perl
And you
and
can-
Ruby have the same problem.
Well,
Same
so
issue.
Ruby actually, those are the guys that actually originated monkey patching.
Yes.
And it's because their system is a little bit more consistent in how it works. Python happens to work the same way, and it's a little bit dirtier, but you can do exactly the same thing in both systems. The Rubyists have like, they've really turned it into like an actual technique. The Python guys have been less bad about abusing it, but it's worse when it's abused in Python.
So if you don't have types and you can dynamically mutate the contents of an object, it seems like you would be continuously dealing with runtime errors. I don't see how do you find them? How do you
You effectively are.
Wow. Okay,
So like
that's terrible.
if say you're looking at this object, so say you instantiate a my handler, whatever the hell that is,
Okay.
as an end user coder, and you call do head on it. What does that method return to you? Does it return anything?
Depends on how the method was coded.
Exactly. So
Ah.
you actually have to go read a lot of Python code or rely on what they call doc strings, which appear as that, just sort of, it knows how to pick that up and will interpret this as your documentation string for that method, which is a really nice, concise syntax. But if that method doesn't have a doc string, now you're SOL.
Oh, I see.
So it's like, for me, it was really common when I was writing Python 5 years ago to call down into that method on the REPL, get the object back, and then enumerate the keys of dict so that I could know what further messages, what further interaction I could have with whatever the hell it was that I was dealing with. Because otherwise it's just completely unintelligible. You have no idea what you've even gotten back. It's horrible.
Well, I mean, like the Ruby guy, they creating a method around that allow you to do it. And so if you call some method doesn't exist, don't just correct it, okay? Call this guy so I can do some further investigation, like you said, go to the dictionary, pick a word in there before I give up. So
But
that's
so I don't see how you create reliability. If you don't have the concept of immutable, and worse, you have
Oh,
the
it's not on
concept
this
of
system.
actually being able to modify a class while you're using it.
You don't think that way, right? There's a different way. When you program in this world, you just have to
Oh,
be.
you just assume everything.
Yeah.
will change. Then you're writing crap tons of defensive code. I don't see how you don't end up writing lots of defensive code then.
You do.
You do.
write-
You do. You,
Oh, okay.
you basically.
And it's interpreted.
Yeah. So if you want to,
Or you don't worry about it.
or you don't worry
Don't
about it.
worry about it,
Yeah. It's a core down. Good old C day, but core down. Let it crash. You know something is wrong.
So how do you get, so if I've got a new coder coming in to take over the code base and the old coder's not around, so how long does it take him to come up to speed then on this?
Jim asked him. He did just that. He integrated power of Ruby code. He's like, what kind of crap is this one?
Okay, wow, wow, that's really attractive as a developer.
You just have
That's- Okay.
No guarantee. But that's not to say, so I think I've given folks the wrong impression.
Or
by
maybe
saying
I
that-
have, because I've asked too many questions.
I have one more question.
Yeah,
right?
because, oh yeah.
Within the My Handler, if we have like a do head, right? If it has like 5 different implementations,
Mhm.
can each one of them return a different result altogether?
Yeah,
Yes.
they can.
They can, right? So that's where it gets advantageous, or?
Potentially, yes, because to go, and I think you had a question, so I will answer that question after I take your question.
Oh, doesn't matter who you take first, but yeah, I was looking at languages about a month ago on a RedMonk and Project Euler and seeing what languages were being used, and I thought Fortran was dead, and I thought C++.
Oh, Fortran is definitely not dead. I've got
Yeah,
friends
right,
that-
right. But I had these misconceptions about the popularity of languages in Python, which I'd like hardly even heard of, and it was just like so insanely popular. Is it primarily popular for education, and it's used less so in the industry, or
No, it's hugely popular.
it's hugely popular? Okay.
Education in Google.
It's
Yeah.
Google's
taking
claim to
over
fame is
Perl,
Python, right?
basically.
Well, and all the Linux distros have moved to Python as their sort of language of choice because it is interpreted and it interfaces with C really well, and
Yes.
lots of people know it. So, and the runtime is actually truly open source.
You know why interface to C so well? Because the VM underneath it's written in C.
Oh, okay.
Yeah,
That's
C-
why
C++.
it makes it easy to bypass it. There.
Right.
Same thing with Google.
So it has its own VM, or
It does. Actually, there are a
It's
couple
an
of
interpreter, right? It's like Perl.
oh, okay.
Yeah.
I mean, in
Oh,
my mind,
oh, okay.
Python, came after Perl. Perl, I mean, if you've done any Perl programming, you know the
Yep.
problems with Perl. Python is better, that's for sure.
Oh, no doubt, no doubt. It's a little more better to
If
me.
you're doing text processing, Perl is
Sure,
better.
okay, so for larger scale kind
Yeah.
of, yeah.
Yeah, if you're doing it, if you have, I don't know why you'd want to, but if you have like multi-gigabyte CSV files, yeah, Perl's actually a really good choice.
Yeah.
So, but never put yourself in that situation. It's terrible to do. So,
I think you have to put on like a different hat when you consider Python versus Scala. You have to think like a little bit closer to JavaScript.
yeah, exactly. Because they're
Versus-
entirely different ways
That's
of
right.
viewing the world
That's
and
right.
getting things done.
Yes.
So going back to your question about polymorphic methods being able to do different things, that is the heart of another pattern called duck typing. Now Scala actually has this, and for a long time it was sort of a major feather in Scala's hat to be able to say that, yeah, we support duck typing. And the basic argument with Python is that types are a limitation. Because if I have something that, you know, walks like a duck and quacks like a duck, I want to be able to duck it. So that's why when things are implemented as maps and you can just sort of send arbitrary messages off to something and it knows how to handle it, you don't really care about the type so much as is it going to handle the messages that I'm sending
Oh,
to
I
it.
see. That's a
Okay.
different way of thinking.
I can give you one close example, right? If you have a JSON file, the Perl, the Ruby, the Python, beautiful, one lousy line, right? Get everything sucked in, and you're done, right in there. If you want to do that in Scala or in Java, good luck, right? Because you have to know all of the type, all of that detail to do that. Holy cow! I'm looking at what is it? Am I regress or progressing, right?
Yep.
So that's what you have to do. That's an advantage and disadvantage of the language. So
Yeah,
you have to
but
understand how to use them.
But the reason that it works well in those dynamic languages is because you ignore the
The
errors.
type.
You ignore the errors.
Exactly.
Right? Whenever you process JSON in Scala, you
You
have to
know
write
exactly.
the crazy code because that code handles all of the possibilities.
Yep.
Correct. Understand that.
JSON is, you might have some data, you might not have the nested piece, it might be an array, it might not be an array, depends on what the response was.
I
right?
see.
But when you write scripting type languages like Ruby or Python or JavaScript, you just refer to something dot something dot something, third element dot something else.
Who knows
And
what
if
they
it
have
works
it?
and it came back correctly, you're all good. And it was one line and it was done.
Beautiful, yeah.
But if it doesn't work, it's going to create an error.
Yeah, pretty much.
Pretty much.
So the way of thinking about sort of message passing should be like relatively familiar to us as Scala programmers if we've dealt with akka. And in a lot of ways, akka is this really high level thing that breaks in exactly the same way as Python.
That's right.
Because you have no idea that the receiver of the message is going to handle what you send it. It's not type safe at that higher level of abstraction, right? So we have the same problems in Scala. We've just shifted them to, oh my God, it's our massively distributed cluster system of 1,000 nodes that looks a lot like Python, but in the large. So when it crashes, it's 1,000 nodes rather than your one little lap. So
Well, it's the same thing, right? Because the message passing, like if you have an HTTP request you send over the network, right? You know what the heck that is. So it say, hey, I don't know about this. You respond back, I have no idea. That's an error, right?
well, so the issue appears because in akka, you instantiate an actor. An actor just responds to things, right? In Python, you instantiate an object. And objects just respond to things, right? It's exactly the same problem. You just switch the terminology.
But
It's horrible.
One of my favorite thing to do with this dynamic language is that all of them have the eval functions.
Yeah,
And
you can take a string
If
and
you
parse it
ever
and
wrote
do
the
stuff.
code, that's like the worm code, the stuff there. So you can actually write the code, generate code, execute the code on the fly, and mutate it over that. And that's what this thing allows you to do. All the static type language, goodbye. You cannot do that.
So when you're writing Spark,
Maybe you shouldn't though. I don't know.
when you're writing
Huh?
when you're writing Spark, are you able to create actors? Are you able to actually use akka and the actors with Spark?
Well, yeah, you should be able to. You should have access to an actor system.
Actually, that layer is abstracted. So when you create an RDD or whatever, right? It uses Akka framework inside, but you don't have to deal with that.
I'm more thinking in terms of if I was using Spark and I actually wanted to have a suite of actors operating with Spark, is that possible? Can I do that? Like, is it, okay, interesting. Okay.
I don't. They probably put security policies around it so that you can't mess with their stuff.
Yeah, I'm not trying to mess with their
But-
stuff. I mean, wherever their latch point is, can that latch point reach into my system of actors? Because I could see me wanting to produce highly parallel things that aren't related to Spark.
Yeah, I mean, it shouldn't be a problem.
Okay.
Well, at least I wouldn't think it would be.
Okay.
So
Hello.
one of the really nice things about Python is that it has remarkably few keywords. It's actually a language that is smaller than C. If you like, C is not a very big language at all. It has like 12 keywords, something like that. Python has like 10. It really is a very small, cleanly put together language, if only because the abstractions it's using can be, leveraged in interesting ways. So there's imports, so you can do packages, and you can rename your imports. So like NumPy is a really popular thing. And the code that we're looking at doesn't really matter here. From, so that you can do other, I don't remember that syntax, whatever it is. Class is a keyword for defining classes. Def gives you methods or actually new functions in whatever scope you're in. One of the interesting things about Python is that it is white space sensitive. So you create blocks through your indentation, whatever your indentation happens to be. So if you mix tabs and spaces, prepare to have fun. And you can actually, your indentation doesn't even have to be consistent between methods. So like in one method, you could have, say, 4-space indentation, and the next method you could have 2. It's really just what lines up becomes that part of the block. So let's find an if down here. Here's a for and an if. This code is indented tells you that it's inside of this if block. And then you could have an else, and then that code would be inside of that else block. It's a really fun thing when that happens. Where you get to the end of the block, is that last line supposed to be after or inside of the else?
Oh, it's definitely not inside of the else.
Well, at this point it wouldn't be.
Right.
But what about at that point?
Definitely not.
It wouldn't be, but what if it was supposed to have
Oh yeah, no, I agree.
Yeah.
I agree.
Or what if that was a space instead of a
Make sure
gap?
your
Yeah.
editor is set up correctly.
Yeah, so there's fun and interesting things that happen that way.
But this is one of the reasons that I say, I'm the guy who really, do it myself. I don't want this. That's why I didn't even turn. When it's Python, go away. I don't even touch it because I couldn't stand the fixed format.
Ah, I gotcha. What's this underscore underscore name underscore underscore? Why that seems outside? What is that?
Down here,
Is that a reference into that map you're talking about?
this is an implementation detail of Python being a scripting language. So when you call Python as a script, now under name gets set as one of these top level sort of variable type things. What you're supposed to do is test the value, and then this tells you your script has been invoked as a top level rather than imported as a package.
I see. Okay. Okay.
So it's one of those weird, like, are you running it as a script or are you importing it, and
Yeah,
it
am I just a
exposes that
component inside of
itself
something?
this way rather than some
In
other.
other words, am I a
thing
main?
like
And that's why it's asking main. Am I a main entry point, or
Yeah.
am I just part of another system who hopefully has a main?
that? Exactly.
It actually
Okay.
have
Because-
reduced usefulness because you can in individual file you do it correctly, and you do this. You can stand alone execute it, or you can use it part of a larger
See that being
system.
on test hook as well.
Yes.
Yeah, it can be.
Yes.
Okay. Yep.
If you were to invoke it as a script, it'd actually be executed, which can be useful and not useful.
Oh, I see. Outside the class, meaning at the root of the document, but
Yeah,
not
because
inside
you
the
can
class.
start writing executable code anywhere in the file.
Okay, got it.
So
It's just that everything that's above that if is really just, well, it's a declaration.
It's a
of
file
class.
system.
Yeah, okay. That's similar to when you put statements inside the block of a class, right? That are
yeah,
inside a
Scala
method.
allows you to do that.
Yeah, so it's very similar model. Okay, got it.
So really the other big thing that Python has, and as far as I remember, this is actually the last piece of syntax, are for loops, which the simple for loop looks like this, where you can iterate over like anything that returns under iter is iterable, I think, in this way. And then you can get, I think the first thing is an index if you want it. So it's sort of an optional piece of syntax. And then this is the value. So if you want to index through the array or whatever it is that's iterable, you can. The flip side of that is that they reuse sort of the same keyword to get what are called for comprehensions. And the Python for comprehensions are incredibly powerful. Like this is their most complicated and powerful piece of syntax. And so like this piece of code that we're looking at right here really tells you, so it's the fact that it's wrapped in curlies tells you it's going to be generating a dictionary instead of a list. And so you can actually optionally, like, you want to generate a dictionary list. Okay, so what you wrap it in is going to define that.
But that's the whole comprehension that you're wrapping, right?
Yeah.
Yeah.
So then these are the keys and values that you're going to output, where the names used in this expression are bound over here on this other side. So then this piece right here is what you're iterating through, because at some point you still have to have, you know, some other collection that you're iterating. Then this is a guard on whether or not you execute this expression. So you can unwrap it in a weird way, but if you look at it, it's, you know, give me a dictionary of key for body of key for every key in the body as long as that key is defined in the body. So it sort of reads English-like, and it's not that bad. And other languages have picked up on this sort of for comprehension style, Angular especially, because they actually have their own expression syntax, unfortunately. They use this in generating your HTML and the Angular templates. Looks very similar, just as powerful, really kind of cool. So, and it keeps you from writing out like, well, this. So you can do in one line what you do in 3 down there.
So is it the opposite of Scala where you have to yield something for it to?
The for loops work completely differently.
Okay.
Yeah, completely
So-
animal. Completely
Okay.
Yeah, it's
You just have to have
this
a-
really is thinking about things in terms of iterators, and this in some sense is just a template that you're filling out the various pieces for. The for comprehension in Scala is a very different beast in that it's literally thinking about monads. Like,
Oh.
give me a list of monads and I'm gonna flat map everything. And that's
Right,
what it's
right,
doing.
right.
For comprehension requires that what's being operated on has the 3 basic methods of a monad. Yep.
It took me a while when it came to Scala to understand the for comprehension. Like, what the heck is that? Because
Me
it's,
too.
I mean, different thing in the Ruby and in Python. I mean,
And Java.
completely different
It's
in
also,
Java.
you come from Java, you get same mental, what?
So let me see if I can find some of the pandas code. So if you haven't dealt with pandas, a lot of this stuff is going to be kind of arcane. But basically what this is saying, we've got...
That's that data frame. This is where you're kind of referring to the data frame
Yeah, this
concept.
is the data frame. So if you guys remember the data frame stuff, pandas is a library for creating data frames. So, and just to give you guys a refresher on what a data frame is, it's effectively a 2D grid where you can have indexes on both the rows and the columns. So,
And that's a core concept in Spark, correct?
that's, yeah, RDD, data set, data frame.
Cool,
that's what it is.
okay.
And the pandas syntax and Spark syntax for data frames look very similar.
Okay.
So, and that is not, that's not a coincidence, that's by design. So like this right here is going to create a data frame from this CSV. So this file is named, where is he? Right here. So we have a tab separated value. We could go look at it, it's not really that interesting.
So in Spark, acceptable format is data frame, other than that it cannot accept any other.
Yeah.
Yeah.
So it has to be data.
Well, it really wants RDD.
RDD can be, I think prior to 1.4 in Spark, it wasn't there. The data frame concept was, I don't know.
Yeah, because they were only using RDD and then they introduced data frame.
data frame after
Yeah.
1.5.
Okay.
If you want to work with Spark, you need an RDD.
Okay.
Yeah. So this code, so what you're actually looking at is a snippet of code that does a little bit of natural language processing. It is a complete and total hack. But the data frame that we're loading up here is for make, model, year associated with words, I think, something like that. And I don't really care if I show you guys this because it's not in production and I don't know if it'll ever be in production. But let's look at some of the stuff because you'll get a sense of just how powerful. Okay, right here. So we've defined our data frame, and now we're just going to take the log of every element in the data frame, and that'll be our next data frame. So we'll just mutate our existing data frame by taking the log of every element. And then we're going to multiply the I guess axis is columns?
You're probably just flipping it, right? Flipping the way you
Yeah, it must
iterate
be
over it.
flipping it and then multiplying
Yeah,
it
yeah.
across. With whatever data frame this is. At one point I knew what this code was doing. I apologize. That was months ago.
That's what
Yeah.
concise is, you can't read it anymore.
Well, but the thing is when you're writing this out and you've been doing it every day,
Yeah.
this stuff is just really natural.
Yeah.
So,
That's what-
After 2 weeks, then you forget it.
yeah.
Doesn't that?
So this much code turned into at least double when I did the Scala port. And the Scala port still isn't finished because I haven't gotten all the type safety down. Because in this data frame, you've got multiple different columns of different types. And it turns out that Pandas doesn't care. because when you multiply a string, it'll just ignore that column. So you can do all kinds of nasty things and it doesn't care.
Oh.
Then you kind of expect your question of why would you want to do this,
Yeah.
right?
Yeah.
It
Yeah.
depends on.
Now you're not so in Scala you're going to have to actually have something that says either filter to only things that are multipliable, or have some none monad crossing them so that you.
So you've got two options. You can either drop the types entirely, which is what Spark does actually, or you can keep track of the types. And so when I did the data frame presentation, I was using Saddle. Saddle keeps track of the column types and the row types, but does essentially unification across all of the columns into a single type,
I remember that.
rather than using an H list.
Okay.
So the issue is that if you have a string and an int, well, what is the least upper bound of a string and an int? It's an any. So now you've still lost all your goddamn type information.
Yeah.
You just have to maintain it all the way through. So now it's just all kinds of pain. So yeah, it's not pleasant.
Okay.
You can address a column named word score inside of your data frame and just assign that as a sum of whatever access you want going across. So this is probably 3 or 4 JavaScript for loops that you can write out as one little line right there in Python.
But would you say that that's specifically for Python, or is that based on the
API.
library, which is?
Well, yeah, the
Pandas?
library. Well, the library is leveraging
Pandas and NumPy, right?
the expressive power of the language.
Yeah.
So you can write this in a way that has an unambiguous interpretation in Python, and then the library just follows the instructions. So there's a lot of hidden magic in Pandas because you're using
Yeah,
syntax in
yeah.
this way, but man, does it make it concise.
Yeah.
So let's see if we can find some
It's
other.
a framework.
Pardon?
It's in a framework.
Yeah, it is a framework.
Framework,
So.
yeah.
I was very pleased because when I had to port this code, I didn't have to deal with like NumPy and SciPy. I only had to deal with Pandas, but that gets fun. So like here you can group by columns. So unstack is fun.
Good.
As I recall, this particular method turned into, so this is what, 50 lines of Python? It easily doubled in Scala to do the same thing.
Because the type.
Because of types.
Yes.
Yeah. And there was one particular piece of code that is actually inexpressible in Python. Or
In
no,
Scala.
inexpressible in Scala, which that was a fun discovery that day.
What is that? I want to see.
Well, so it actually has to do with duct typing. And it has to do with how the data frames are keeping track of the index types. So in this particular piece of code, it was being very flexible in doing its scoring with what tables it was looking at. So we could either score our free text search by car make and model, or car make and model and year. So because one is a 2-tuple and the other is a 3-tuple, Python doesn't care because what you're just returning is a data frame. So the pandas data frame underneath has now this 3-level index or 2-level index, depending on the query that you've typed in. Now the code doesn't care because you're either make model or make model in year, and so you can either look at the year column or drop the year column, but you really don't care what the index is. Your code can handle it later on because you always know that you're going to have these first 2 columns. When you translate this over to at least Saddle, I think Spark would be a lot cleaner this way, because you're just going to completely drop the types. When you move it over into Saddle, that return type of whether or not it's a 2-tuple or a 3-tuple now has to be bound into something useful, which should be an any at best. And so you just, all of the flexibility that you get on the Python side, you try and unify these things just like, well, I get an any. Yay.
Yeah.
Because now I can't do anything with it. So
What is Saddle?
Saddle is more or less a direct port of Pandas to Scala.
Oh.
Yeah. It's actually a really nice library. I love working with it, but types in this instance actually end up being your enemy because, and this is something that I sort of had to think my way through. when you're working with arbitrary data, especially in a framework like this where you don't know if you're going to be reading numbers, ints, strings, enumerated values, it could be functions for all you know. The types are going to hinder your ability to process the data, because you really want to be able to say things like this, where I want my index, and I want to re-index, which is what actually this code is doing, and then drop everything that just doesn't have a value. Expressing that where you now have to care about all of the types and the indexes, or like every cell in your grid has a type and you have to care about what that type is, and then do an appropriate comparison to whether or not it's empty, it's really painful. So
I face the same problem because I have to display a grid data, and the element could be any kind, but I need to interpret them. I cannot use any, so I convert everybody to the string.
Yep.
And therefore, because from string you can still do a little computation, you can infer the type from there.
Yep.
But any forget it, because you cannot coerce it to anything. You don't know.
I mean, you could downcast it, right?
Right, but then you have to make a guess. Is this kind, this kind, this kind, this kind?
And you've lost pattern matching even on the cell. So in other words, you
Right, the
lost the type from the cell.
Right.
You're going to only have the type for the table. Is that what you're saying?
Sometimes it does work. Sometimes it not. Depends on the structure. Some occasion the code works, and then when they try to apply the same trick to something, it won't compile. They're like, what the heck? And so it's
it's not that it can't be done. It's just that as instance of
Yeah.
is something that you're going to be typing all over the place.
Huh. Okay.
So,
and you as of instance of something that does not belong to that, you got the
Oh yeah, runtime error. No, I got it. Yeah.
yeah.
I think that's most everything. Oh, they introduced annotations at one point, which
Well,
can
given
do
that
cool
though,
things.
what you were just saying is, in Python, if it's going across doing multiplication and it hits a string, it just ignores it, right?
It can, yeah.
So technically, that is an error, and it's just ignoring the error.
Because it assumes that the coder, that the data scientist putting his data together, knew enough that that's just not going to be an issue.
So, can't you do the same thing with, oh, I see. You're saying you do the as instance of, well, yeah. So you do the as instance of number, and then you do the operation. And if the as instance of number comes back as a failed, notice if you fail that, then you treat it as an error and you skip it.
Yep.
Is that essentially your implementation strategy in Scala?
That it ends up having to be that.
Oh, okay, got it. Okay.
Which is really important.
So you're more explicitly having to implement it, where in Python it has it already implemented. Okay, now I got what you're saying. Okay.
So I don't think there's any more syntax to look at.
There's no keyword yield in Python.
No keyword what?
Yield.
Yield?
Yeah.
There
That's
might
in
be
Ruby.
generators. I think
There is.
there is. Okay.
Yeah, but it means differently than the yield in Scala.
Yeah. It's something.
Oh, yeah.
Yeah.
So, there is a lambda syntax these days, which is nice.
If we go lambda,
So what other interesting things could we talk about? I see Jacob putting together an amazing presentation back there.
As the pressure builds.
I'm close to ready.
All right.
we can
So,
move it to the next
what
one.
questions could I answer in relation to like Python and Scala? That-
Python looks like it's not an achievable target for us, at least. I definitely know that. Maybe.
but why not? Why wouldn't it be?
That's my feeling. Maybe it could be wrong.
Well,
How did it start? Like, was it easy to grasp or like?
Python?
Yeah.
Yeah, it's really quick and simple to start, because like you can look at this code and knowing nothing about the language, you can probably tell what it's doing, right? There's some magic here, like this stuff. You don't necessarily know what the methods are doing, because there's some hidden syntax there. But the general structure of the code and what it's doing should be obvious to like anybody who's gone through first year computer science, because it's the same keywords. They're used in a very familiar, friendly way, And so it is very, very quick to pick up.
So your data scientists picked this up, right? They didn't know it before, and they're not software engineers.
They may have taken a Python course back in school. Where I went to school, their very first course that they're teaching people in is Python.
Okay.
So,
So what your data, kind of to speak more to the need here.
Yeah.
So if someone is actually wanting to use Spark, and they're not necessarily, their primary function isn't a software engineer, Python's probably better than either Scala or Java or even Groovy.
it really depends. So like one of the big hurdles for us is this is like 1,500 lines of Python that now has to be turned into something that we can put in production.
Okay.
It can run as a toy model back on a data scientist's desk. But the moment that you want to put this in front of 1 million people, it has to come to me and I have to turn it into real production-worthy code.
And so what do you use for production-worthy code?
We use Scala and Java.
Okay, gotcha.
So-
So Python is good for the people who are implementing these simple models for.
They can be incredibly complex. Like this code right here is probably, 50, well not 50, but 10,000 lines of Java for what it's actually doing, just because there's all this array manipulation.
Yeah.
So the actual content of the logic is relatively light, but the amount of extra boilerplate.
So why are the data scientists, why are they originating in Python then?
So, well, a lot of it is the ecosystem and tooling that you have. So you have languages like Pandas that is a top notch. Like it's probably better than the Spark data frame library for ease of use and productivity.
Oh, I see.
These guys can get more done more quickly in this language and ecosystem.
So instead of slightly different way, using their own laptop, using Pandas and Python, they can actually model and fiddle with a small partial data set, get what they want done, and now the movement to production is a push to you, and you're the one that does the translation of the Pandas and the Python into Scala code. Is that what I'm hearing you say?
Yeah. So
Okay.
if we take a look at,
I was just saying, I think Mark's situation, who knows what all factors went into this decision to not run the Python as is in production. But there is certainly a ton of Python related code running in extremely
okay.
large systems.
Yeah, in the even
there
web
is, but you have to
serving and
dedicate
everything
way
else
more
in that
resources to it.
Yeah, well, yeah, so there you go, right? So his volume is high enough that it's a
I
factor.
see.
But if you're not doing the type of volume that that they have to do,
I get
then ship it, right? So it just depends on.
And his is more live volume, where if you're just doing a data warehouse reporting slash, you
sure.
don't may necessarily need that resource efficiency.
Depends on your
Is that what you're
data.
saying?
We actually have real latency concerns. So we go through and we want to
okay.
rescore
You're hyper.
every single car listing in the market every 15 minutes. We cannot do that using Python. It's just not physically possible.
So you do actually have a specific need for the efficiency, where potentially other people are not looking for that same level of turnaround.
I had Scala code that was running as fast as it physically could, and it was not fast enough.
Okay, wow.
Yeah, so these laptops have a 25 gigabyte per second memory throughput bandwidth. That's the theoretical peak. I was getting about 50% of that, which is about what you're gonna get without dropping down into C. That was not fast enough. I spent weeks trying to make it faster.
Wow, okay.
So
you had to drop down to C?
we're gonna drop down to C on
Oh,
the next
okay.
version, actually, yeah.
Uh.
Because it's just not fast enough.
What was your question?
Like if you put Python directly to production, you're not gonna get that efficiency, that's what you're saying.
You could, but it would be really hard.
Okay.
And the latency impacts that you're going to have are going to be much greater. So, and actually the Python, the rest of the JIT and the garbage collector, just not as good as Java. So
Yeah, for sure.
So that's why, like, if it's a real serious production, if you're going towards any data warehouse or any of that stuff, do you recommend going with Scala?
Well, what is real definition? What is real production? Right.
Well, what's latency? I don't know what the definition of latency is here.
2 milliseconds is too
You're
long.
servicing a
2
customer.
milliseconds?
Yeah.
Okay.
A corporate customer, for example.
So if you've got an overnight processing, in other words, if you've got daily collection and you're doing an evaluation overnight, so you can drop it to say agents the following morning, latency, this 2 millisecond latency might not be an issue, right? But if you actually have sales agents who are needing to know the information as up to date as possible. It sounds like they've got a 15-minute cycle on their entire data set. Then now it sounds like you don't have an 8 or 12 hour overnight window, you have a 15-second window. So it sounds like latency is the strongest, it's the constraint evaluator. That's really what I'm hearing.
There is a lot of that, yeah.
So I don't know your business model, but yours does seem somewhat unique in what you're doing there.
Yeah, we're doing weird things.
Yeah, but I'd say many businesses don't think like it. You're thinking in internet squared time. Many businesses can't even think of internet time.
So like
yet.
the 2 milliseconds isn't a request response time, it's actually a model scoring time.
Gotcha, yeah.
Like our models were taking 2 milliseconds to score actually a listing. That's just too long.
And you weren't able to. Are the records attached in a way where you're not able to expand?
So it is parallelizable, and we need to put everything into Hadoop. And
Okay, so
that
you
will
are
be
doing that
much
evaluation,
better.
but you
Yeah.
have 2 milliseconds on a million records sequentially is different than 2 milliseconds
Yeah.
on a million records across 100 servers, right? So,
But
have
then
you-
we were running into problems because it's not as if the model is small. So these little Hadoop nodes actually run out of memory because they only have like a gig of memory, and we couldn't load the models in. So fortunately, the new model that will be going to production is
you
much
mean the
smaller.
actual process of the 2 millisecond, the model representing it, which each node has to have in its entirety, even though
Yeah.
it's got some subset of records. I get it now.
Yeah, there are lots of weird constraints going. A really simple model. Well, if I were to explain it, it's really
It's
simple.
okay. I'm more trying to
So-
figure out what the business complications are around the implementation. It's taking a gig to implement a simple model in Hadoop, then that means that the scalability is actually negatively impacted. That's,
What if we can get lots of 1 gig nodes, and we actually have a lot of our own hardware?
oh, I
So,
see. Okay.
Yeah, it's not really that bad. So it just needs to get better. So it can be fixed.
So
Thank God.
one of the reasons that the popularity of the Perl and the Python is that a lot of it allows a non-software person to write the code. So I have a whole bunch of engineers who know good in circuit design, but they want to do some simple thing that's stitching together. So they just write in Python and they carve up the sequence of stuff to do and run it. So they run little dirty little script, don't have to worry about function calls or any of that stuff, so they can carve that together nicely. And so that's what is very popular among they call the electronic design automation industry. So it's very popular. In that, and besides a tickle also, so I have a tickle.
Oh God!
Oh, no.
So-
Which I have to deal with also.
Oh man.
Yeah.
So we can go through a little bit of this because I think this will help answer your question a little bit. The data scientists that I work with actually live in what they call a data notebook, and it's basically a really, really fancy REPL. So what they can do is they can write their code here. This is an environment called Beaker.
You know what a REPL is,
Yeah,
right?
yeah.
Okay, good. Sure.
The guys that I work with actually use Jupyter because it's really highly focused on Python. It's also been around a long time, so it works really well for them. I brought this one up because I was doing a presentation because this one speaks Scala and Python, and you can communicate between them, which is really neat. So our guys, they will start with a data science problem and just start hacking together random code. So like this is Python code down here that eventually will start printing stuff out. And so the thing with a data scientist is you need the iteration and you need the intuition to know what parts of the data are important. Because you're not just going to a priori know, oh, I need that feature and that's the feature that everybody cares about. There might be somebody with 25 years of business domain knowledge that can tell you that. But if you're just getting into the domain, what makes cars sell? Like, what is the most important aspect of it? Even that is actually a misleading question because that most important aspect might only explain 5% of the variance or 10% of the variance as it turns out. Which we found out because we do price prediction models. The most important aspect of cars still only explains 10% of the variance of cars.
Isn't that wild?
Yeah, so you need 1,000 other things to do anything useful. The way that you develop that intuition is by playing with the data, get really quick turnaround time, and then getting graphic visualizations, which is why they use data notebooks in the first place. The tools that we as software developers use are like IDEs and build systems, and we're not developing that intuition or tools for that.
Yeah.
Which is why Python is great because if I need to write something out quickly, I don't want to be writing out types. That is literally a waste of my time because it hinders my ability to quickly intuit what's going on.
An analog would be the Scala worksheet for developing functions and playing with code. I mean, it's analogous as a software developer, but okay.
Yeah. So that's why they use this, because you don't even care if it crashes. You're going to take an extra second. Oh, I need a not a semicolon, but an extra paren. Okay, it's good. Let me run.
Gotcha. Okay.
So,
So you can compare Scala code and Beaker?
yeah. This
That's
is
right there.
This is a tiny little bit of Scala. We actually have more Scala down here. This is Spark, but it's Scala code that is doing Spark stuff. So, yeah, actually, if you want a better REPL, here's a really interesting one. So, I don't know that I'll be using it, but
See, like when the when see that the reduce with the function in the inside there.
Yeah.
Initially, look at what
yeah.
the heck is that, and then after a while, I'm using it naturally after a
Yeah.
little bit. So I cook up all my own magic in that too.
And that's browser based, so that's actually,
yeah.
got it, very nice.
Yeah, there's a service running in the background. That's cool stuff.
Yeah.
So I know I didn't really give you a clean and clear cut answer because they're
No, it's good. Thank you.
okay.
We try to do that in Java, just that kind alone there, right? In that Scala. code.
Oh yeah, this would be no fun.
Yeah, it would be no fun.
So. All right, let's hear a little bit about Scala Z.
Come on, Jacob.